This video instruction is for Chapter 9 in the Basic Electricity book on compound circuits. The objectives you see here, the first diagram is a resistance in series with a parallel combination. You see the R1 is 5 ohms, R2 is 10 ohms, R3 is 20 ohms. The 10 and 20 ohm resistors are in parallel, so we need to find the resulting resistance, or the resistance of those two in parallel, and we're going to use the formula that I showed you, which product over the sum. We're going to take 10 times 20 divided by 10 plus 20. That's going to give us 200 divided by 30, and the result of that is 6.67. So the resistance of those two parallel resistors of 10 and 20 is 6.67. And you see on the next slide, that is the result. And now we're going to just simply add 5 plus 6.67 to get 11.67 ohms. That would be the total resistance between point A and point B. For the next diagram, shown a little bit differently here, we have two resistors in series, a 5 ohm and a 10 ohm, but they are parallel with a 20 ohm resistor. So the first thing we need to do is find the total resistance of R1 and R2. And since they're in series, it's as simple as adding 5 plus 10. That gives us 15 ohms. So the result is a 15 ohm resistor, which you see circled there, or the equivalent of 15 ohms, and then a 20 ohm resistor. So you see the equivalent here, the 15 ohm resistor, the 20 ohm resistor. Again, we'll do product over the sum. That would give us 15 times 20 divided by 15 plus 20. The result of this is 300 divided by 35, and that comes out to about 8.55 ohms. The next diagram in the presentation shows a circuit where we have a 30 ohm resistor, a 10 and 20 ohm resistor in series. The 10 to 20 is in series, but they are parallel to the 30. So the resulting resistance of these two is actually a 30 ohm resistor. And now you can see that we have two 30 ohm resistors in parallel with each other. The equivalent circuit resistance is going to be 15. Pretty simple math on this, because 30 times 30 divided by 30 plus 30 is 900 over 90. Actually, that is 900 over 60, which is equal to 15. The next compound circuit we're going to look at, we're going to use current involved with this circuit. There are two resistors, two 12 ohm resistors in series here, and then the 24 ohm resistor, which is parallel to that. Of course, the equivalent here is 24 ohms, and when you put two 24 ohm resistors in parallel, do the product over the sum, that would equal a 12 ohm. Now that we know that our total resistance is 12 ohms and our voltage is 24, we know that there are 2 amps flowing through the circuit, and since each branch has the same resistance, the amount of current through each branch is going to be the same. So we just divide that 2 amps between the 2 branches, and that would give 1 amp for each branch. The next circuit is shown in the book on pages 63, 64, and 65. It's quite complicated. But if you wanted to first find the total current through the circuit, we need to find the total resistance in the circuit. So we'll start with our first parallel set of resistors, the 3 ohm and the 6 ohm. And if we do the product over the sum, 3 times 6 over 3 plus 6, that's going to be 18 divided by 9, or 2 ohms. So the result of R1, R2 is 2 ohms. It's in series with a 4 ohm. So this circuit up here is actually going to be 6 ohms. It's in parallel with a circuit that is 12 ohms. So we need to find the total resistance of that 6 ohm and 12 ohm. That would be 12 times 6 divided by 12 plus 6. And that would give us 72 divided by 18, which is equal to 4. So the actual total resistance of the circuit here with R1, R2, and R3, and R4 is going to be 4 ohms. Since all the current is going to go through R5, and then we have the 4 ohm, now we know that the total resistance is the 8 ohms for R5 plus the 4 ohms of the 4 additional resistors, or 12 ohms. And then when we look at our 54 volts divided by the total ohms of 12, we come up with 4.5 amps. So now that we know the total current is 4.5 amps, we know that's the total current going through R5. When we get here to this junction where the current is going to go 2 ways through the parallel circuit, we know that the total resistance here, when calculated, was 6 ohms, and the total resistance of R4 is 12 ohms. We know that 2/3 of the current is going to follow this path, and only 1/3 is going to follow that path. So if we took the 4.5 amps and took 2/3 of that, that would be 3 amps and 1.5 amps. And again, to find the current that would flow through R1 versus R2, this is 1/3. Excuse me, this would be 2/3, which would be 2 amps. This would be 1/3, which would be 1 amp. And of course, through R4, or excuse me, R3, the 4 ohm resistor is going to be 3 amps.